So today guys we'll be learning about logic gates. So we've got a NOT gate here, as you can see right here. Then we've got an OR gate, an AND gate. Look at those closely. Now this is what the definitions are for logic gates. They're not in order, but this is what they are. But I'm going to simplify it, okay? So what the first one is saying is that if one of their poles are true, then if both are true, like if both are on, then this one's on, so the output. So two inputs are on, the output's on. Yeah, that's an OR gate. Yeah. And then what comes next? Let me have a look. Right, so a NOT logic gate, it says, which has one input, all gates have one output. So, a NOT gate basically is the opposite. So, if you put an input in, let's say you put 12 volts in, you'll get nothing out. And if you take 12 volt off, you get 12 volt out. It's the opposite basically. So if you put voltage in, you don't get any voltage out. But then you put voltage. If you don't put voltage in, voltage comes out. It's really weird. Let me just see. Let me just look at definition for an AND gate. Right, I'm going to do voiceover right now because my microphone cut out. But basically, I couldn't find an AND gate on the text I'd got, so I found another text and I'm going to explain it to you. What this is saying is, if you get one input and one, if you get two inputs, you get an output. And if you get only one input and then you'll get no output. Let me get a better example. And let me just delete it. And that. Right, and then for AND gate, I'm going to put in something to help you. Right, so for the AND gate, it's, imagine, because in binary, 0 means off and 1 means on. Just remember that. So if we have off plus off, it equals off on the output. yeah? And if we have an off and an on, it will equal off and an on. So, it equals 0. So, if we have 0 and 0, which means off and off, it equals off. And if we have off and on, it will equal off. And if we have on and off, we will have off. Now if we have on and on, it will be on, if that makes sense. Now we have this. So if we have off plus off, we will get off. Remember, this is the OR gate. So now if we have an off plus on, it will equal on. Yeah, it's slightly different. And if we have on plus off, it will equal on. Now if we have on plus on equals on. Yeah? You understand that? If not, comment down below and I'll try and make another video that's simpler. But now we're going to do the NOT gate. Right, so this is the NOT gate. It's really simple, this one. Basically says if it's off, the input, on the output it'll be on. And if the input is on, then the output will be off. It's the opposite way round basically. They just do the opposite of what you tell them to do. Which in some applications you'd want them, but my applications, I don't often use them. I do use them sometimes, but not often. I usually use the AND gate or the OR gate. Yeah, there is other logic gates, but we won't be doing that in this video. Maybe a video in the future. But yeah, now we're gonna wire up the gates, and I'm gonna leave these at the bottom so you remember. Actually, I'm gonna leave them next to the actual one.